Welcome to Understand the Math. In this video, I'm going to teach you the basics of complex numbers, what they are, how to add, subtract, multiply, and divide them, and then we'll look at some examples where we will simplify powers of complex numbers as well as radicals. By the end of this video, you'll be able to confidently work with any complex number. Let's get started. A complex number is any number that can be written in the form a plus b times I. A is called the real part of the complex number, and b is called the imaginary part of the complex number. The letter I is an imaginary unit, and it's equal to the square root of -1. And then if we square both sides, we can see that I squared is equal to -1. And we'll use both of those definitions in our example problems. In the first examples that we're going to look at, we are going to identify the real and imaginary parts of the complex number. Let's look at our first example. With this complex number, our real part is equal to 3. And then our imaginary part is the constant that multiplies I, and in this case, it's equal to -4. Let's now look at our next example. This one doesn't have an I in it, so it's not going to have an imaginary part. So for this one, we just say that the real part is equal to 6, and then the imaginary part is equal to 0. Let's look at our third example. In this example, we only have a constant that multiplies an I, and we don't have another constant. So our real part is equal to 0, and then our imaginary part is the number that multiplies I, and that, in this case, is -5. Let's now look at some sum and difference examples. These are examples where we are going to add and subtract complex numbers. When we do example problems like this, what we're going to do is we are first going to combine the real parts, and then we're going to combine the imaginary parts. Let's look at our first example. I'm going to underline the numbers that are our real parts, and we're going to combine those. So we have a 4 minus 3, and then we're going to have our imaginary parts. I'll underline those with 2 lines. Those are imaginary parts, and those are equal to -2 plus 5 times I, and then all we have to do now is simplify. 4 minus 3 is 1, and then 5 minus 2 is 3, so we have 1 plus 3I. And we'll highlight that. Let's now look at our second example. We're going to do the same thing. We're going to combine the real parts, and this is -3 minus 5. Here we have to watch the negative a little bit. And then we're going to combine the imaginary parts. We have an I by itself, so the constant that multiplies I is 1. So we have a 1, and then we have a -6 from our second piece. Let's now simplify. This is -8 plus 1 plus 6 times I, and this gives us a -8 plus 7I. The next examples that we're going to look at are what we call product examples. In these examples, we're going to be given 2 complex numbers, and we're just going to multiply them. When we multiply 2 complex numbers, we have to use the FOIL method. That's when you multiply 2 binomials. The FOIL stands for first, outer, inner, and last. I have a video on that if you need to review it. After you use the FOIL method, you're going to simplify the product, and we're going to use I squared is equal to -1. Let's look at our first example. We're going to start by using the FOIL method. So we're going to multiply the first terms, and that's 5 times 3. That's the first term in each expression, plus the outer terms, and that's 5 and -2i. So that's FO, and then I stands for inner, so we're going to multiply the inner terms. That's 4i and 3. And then lastly, we're going to multiply the last terms, and that is going to be a 4i times a -2i. Now all we have to do is simplify. This gives us 15 minus 10i plus 12i, and then we have a minus 8 times I squared. Let's now combine terms, and then we'll substitute in that I squared is equal to negative 1. We have 15, and then we have 12 minus 10, so that gives us a 2i. And then we have a minus 8, and then we'll plug in minus 1 for I squared. This is 15 plus 2i, and then a minus 8 times a minus 1 gives us a plus 8. And then we can combine the 15 and the 8, and we get 23 plus 2i. And let's highlight that answer. Let's now look at another example. I wanted to include this one because it might not seem obvious right at first what to do. When you have a complex number that's squared, in order to evaluate it, you can just rewrite it as two complex numbers multiplied together. So this is 2 plus 3i times another 2 plus 3i. Now we can go ahead and use the FOIL method. Our first terms are 2 times 2, plus our outer terms are 2 times 3i, and then our inner terms are 3i times 2, and then our last terms are 3i times 3i. Now let's simplify. This is 4 plus 6i plus another 6i plus 9i squared. This gives us 4, and then 6 plus 6 is 12, so we get a 12i. Now we're going to plug in that I squared is equal to minus 1. And then our final answer is 4 minus 9, which is minus 5, plus 12 times I. And that's our answer. Now let's look at some quotient examples. These are examples where we are going to have two complex numbers and we're going to divide them. These are hard, and I'm going to walk you through these step by step. When we divide two complex numbers, what we have to do first is multiply the numerator and the denominator by the complex conjugate of the denominator. You may not be familiar with a complex conjugate, so I'm going to write down what it is. The complex conjugate of a plus bi is just a minus bi. Then the second step is we're just going to simplify the quotient using I squared is equal to minus 1. Let's walk through our first example. The first thing we need to do is multiply by the complex conjugate. This is our denominator, so we're going to multiply by the complex conjugate of that denominator. And when we multiply, we can't change the problem, so we have to multiply on the top and the bottom, and that's just like multiplying by 1. We're going to multiply by 3 plus 2i. All you do is you just change the sign of the term that has the I, and you do that on the top and the bottom. So really, this is just multiplying by 1. So we're not changing the problem. We're just making it easier to work with. Now we have to use the FOIL method. So we're going to use the FOIL method on the top. So we have our first terms, which is 2 times 3. And then our outer terms, which is 2 times 2i. And then our inner terms, which is 5i times 3. And then our last terms, which are 5i times 2i. Now we're also going to use the FOIL method on the denominator. Our first terms are going to be 3 times 3. Our outer terms are 3 times 2i. And then our inner terms are minus 2i times 3. And then our outer terms are minus 2i and 2i. Now let's simplify and we'll see what we get. On the top, we're going to have a 6 plus 4i plus 15i plus 10i squared. And on the denominator, we're going to have a 9 plus 6i minus 6i minus 4i squared. Now let's keep simplifying. On the top, we're going to get a 6 plus 19i plus 10, and we're going to plug in that I squared is negative 1. And then on the denominator, we're going to get a 9. The 6 i's cancel, and we have a minus 4 times minus 1. On the top, we have 6 minus 10, so that is minus 4 plus 19i. And then in the denominator, we have 9 plus 4, which is 13. And we're going to rewrite our answer as minus 4 over 13 plus 19 over 13 times I. And that's our final answer. Before we go on, I want to point something out to you. Did you see how our denominator ended up as just a constant and it had no imaginary term? The reason for that is when we multiply by a complex conjugate, like we did here, we had our denominator term and we multiplied it by the complex conjugate. You will always get a number that doesn't have an imaginary piece. When you multiply the outer terms and then the inner terms, they always cancel each other out because they're opposite in sign. Let's now look at our second example. The first thing that we're going to do is multiply by the complex conjugate. So remember, the complex conjugate, you just take the number and then the term that has the I gets a negative. So we're going to multiply by minus 5i on the top and minus 5i on the bottom. On the top, we have a minus 1 times a minus 5i plus 4 times minus 5, and then we have an I squared. In the denominator, we have 5 times minus 5, and then an I squared. On the top, we have 5i minus 20, and then we're going to plug in that I squared is negative 1. And in our denominator, we have 5 times minus 5 is minus 25, and then our I squared is negative 1. In our numerator, we have 5i plus 20. We'll have to rewrite that and change the order here in a minute. And then in the denominator, we just have a 25. Notice that each of those terms is divisible by 5. So let's divide the top terms by 5 and the bottom terms by 5. This gives us I plus 4, all divided by 5. And now we're going to go ahead and let's rewrite this. This is equal to 4/5 plus 1/5 times I. And that's our final answer. Hopefully you're starting to get the hang of this. Let's look at a few more examples. The examples that we're going to look at now are called power examples. For these examples, we're just going to have the term I, and it's going to be raised to a power, and we're going to have to simplify it. To do the simplification, we're going to use I squared is equal to negative 1. The idea behind these problems is that we want to reduce each power of I to a power of I squared. In order to do that for our first one, we're going to rewrite it as I times I squared. Then we're going to plug in that I squared is negative 1, and we get a final answer of minus I. Now let's look at our second one. Again, we want to write this as a power of I squared, so we can think of 10 as being equal to 2 times 5. So we can write I to the 10th as I squared raised to the 5th. Our I squared then is negative 1, and we have negative 1 to the 5th. So negative 1 raised to an odd power is going to be equal to negative 1. Now let's look at our third example. We can't divide 35 by 2, so let's make it an even power and let's rewrite this as I times I to the 34. And then we can use that same technique that we did for number 2, And we can say that 34 is equal to 2 times 17. So we can write this as I times I squared to the 17. Now we'll plug in that I squared is -1, so we have I times -1 to the 17th power. -1 to an odd power is -1, so this just gives us an answer of -I. Let's now look at one more set of examples. In these examples, we are going to be given a radical. That means a square root of a number. And we're going to have to simplify the expression. In order to simplify the expression, we're going to make use of the fact that the square root of -1 is equal to I. Let's look at our first one. What we're going to do is we're going to break apart the -8 and write it as -1 times 8. So this becomes the square root of -1 times 8. And then we're going to do the same thing to our -18. We're going to write it as -1 times 18. Then we can pull out the square root of -1 as an I. So this is the square root of 8 times I plus the square root of 18 times I. Now we can go ahead and simplify. The square root of 8 is 2 times the square root of 2. And then 18 is 9 times 2, and the square root of 9 is 3. So this just becomes 3 square root of 2, and then the I comes along for the ride. And then we can just combine these. We have 2 root 2 plus 3 root 2, so we end up with a 5 root 2 times I. Let's look at our second example. Notice that in this example, we have two radicals that are multiplied together. We're going to start with the same way that we did with the first one. We're going to rewrite the square root of -12 as the square root of -1 times 12. And then we're going to multiply this by the square root of -1 times 9. This gives us I times the square root of 12 times I times the square root of 9, which is going to be 3. We'll write that down on our next step. Let's think about this. 12 is 4 times 3. So when we take the square root of it, we can pull out the 4. Square root of 4 is 2. So this becomes 2 root 3 times I times the square root of 9, which is 3 times I. Let's rewrite this as 2 times 3 is 6. So we have 6 root 3 times I squared. And now we can go ahead, we'll give ourselves a little bit more space here. I squared is -1, so we have 6 root 3 times -1, which gives us a final answer of -6 times the square root of 3. And that's it. I hope that you now feel more comfortable with working with complex numbers. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.